The question we are going to discuss today is LeetCode 134 gas station. It's been an all-time favorite question for Meta and Amazon in their last 1 month of interview rounds. So let's see what does this question say. But before I explain the question to you, I would like to let you know that this is a greedy method solved question. And if you have solved it, you will be able to do it in the optimum manner. Otherwise, if you have not solved it and you're looking at it for the first time, you would get a solution which is not that optimum, which is O of n square time complexity. And I will explain you why. So what does this question say first? You have been given n gas stations along a circular route. And all those gas stations have certain amount of gas. At the ith station, you can say the gas is gas I. And you have a car with unlimited gas tank. And it costs around cost I, and that is a cost array given to you as shown in the example here. So you have a gas array and a cost array. And the cost is the cost of gas to travel from ith station to I plus 1th station when you are talking about cost time. So you begin a journey at any point of time with an empty tank at one of the gas stations. You have been given two integer arrays like I told, gas array and cost array. And you have to return the starting gas station's index such that you never run out of gas when you're traveling around the circuit once in the clockwise direction. Otherwise, if that is not possible, you have to return -1. If there exists a solution, there would always be a guaranteed unique solution. You cannot have multi-solutions. So this solution is better explained by an example. So I will take this example here. You have a gas array and these gas stations are organized in a circular manner. So gas 0, gas 1, gas 2 are different gas stations, okay? And then this cost is the amount of cost you have to pay for the gas at that particular gas station, okay? So how can you buy a gas at a gas station when your gas minus cost difference is positive? If your cost is more while the gas you have is less, at that time you cannot have the gas at that gas station and you will run out of gas. So you have to take the entire clockwise round or circuit around the gas station, starting from any one gas station, and not run out of gas. That's your question. So you have to return the starting index of that gas station that makes all of this possible. Okay. So how to find that gas station? So we have a gas array here, 1, 2, 3, 4, 5. And we have a cost array here, 3, 4, 5, 1, 2. So your starting index or your any index should be such that you don't run out of gas, which is possible only if gas minus cost is positive, right? So I have a difference array where I subtract corresponding elements here. So 1 minus 3 minus 2. That means that if you start from this index, at that time, your cost is 3, your gas is 1. So 1 minus 3 minus 2, that is you're 2 short, okay? Then 2 minus 4 is -2, 3 minus 5 is -2, 4 minus 1 is 3, first positive, and 5 minus 2 is 3. Now you have also been told that in any scenario, you will have only one unique solution. So there cannot be more than one solution is correct. So if you have found one solution, you can let it be. You don't need to find for next solution, okay? Now, how do you ensure that there would be a solution? So to ensure that there would be a solution, your sum of gas required should be positive and should be greater than your cost of gas. Because any time greater than or equal to, because any time if it is less, in that scenario, your cost is more, so you will run out of gas. So that is your first check you need to do. After that, you follow the greedy algorithm and you run on this difference array. And in this difference array, you find one starting index and then see if your total is positive or not, which is negative here. Then you go to the next index and you see if your total is positive or not, but it is negative, so you cannot start here. Now you go to the next index and you see if your total is positive or not, but it is again negative, so you cannot start here. Now this is the first index where your gas minus cost is positive, so you can start here. Say suppose you start here and then you take gas from here, so you have 3 gas right here. Now you go to the next gas station, you still have positive, so 3 plus 3 is 6. Now you have to go in clockwise manner, so you check 6 and subtract all of the negatives. So all of the negatives are -6. So 6 minus 6, that is 0. But you are able to take the clockwise turn That means you are able to fulfill the entire circle without running out of gas. Your sum of gas is equal to cost of gas. Hence, your solution exists. And your starting index would be this index. That is 0, 1, 2, 3, third index. And that's your output here. So basically, you will start at third index. And that's how you will be able to finish the entire clockwise circle. Now, you'll ask me that the last index also has a positive difference. Can't we start from here? So if you choose to start from there, in such a scenario, you have 3 here, but you have -6 here. So 3 minus 6, that is -3. You already ran out of gas. So that is not a possible solution. Now look at example 2. In example 2, you have 2, 3, 4 as the gas array and 3, 4, 3 as the cost array. So if you first check the sum of gas is 4 plus 2, 6 plus 3, 9, whereas your cost is 3 plus 3, 6 plus 4, 10. So your cost of gas is more than the gas. That means you will run out of gas and your output would be -1. So I hope you understand the question very well. And the approach we are going to take, it's a greedy method solved solution. Now, what if you have not seen this question before and you're doing it in the interview for the first time? I'm not saying you cannot do it. I'm saying that you can do it, but your approach would be the basic approach which I would have taken if I have not seen this question. So what my approach would be, okay, I'll go through gas array, I'll go through cost array, I'll pick up one pair gas and cost here. I'll start from this index and then I'll run through the entire gas array to see if somewhere I run out of gas. So then if I run out of gas, I'll move to the next index and start from there and take a clockwise circle and see if I run out of gas. Then I'll move to the next index and see the same. So in such a scenario, I'm running through the entire array, so O of n, but with every index when I'm starting, I'm checking for the entire clockwise array, right? So O of n square. So I'm essentially running the loop twice. So my time complexity would be O of n square there. But with this approach, I don't have to run the entire loop. I just have to find a index where the difference is positive. And since I've already checked that sum of gas is greater than equal to cost of gas, I don't have to check for the entire array. I just need to check until the end of this difference array. If I found a starting point which is positive and I can see that until the end of the array, the total remains positive, then that index is my answer. I don't need to run it and check for the entire array. I know it's not very intuitive, but this approach is like, if you know it, you can do it. If you don't know it, you'll somehow do some complexity. So let's start coding it, and with the code, you will understand it better. So first of all, I handle my default condition, which is if my sum of gas is less than my sum of cost. In such a scenario, my solution does not exist and I will run out of gas. So my solution would be -1. Now, if this is not true and we go ahead in the loop, in such a scenario, I'll check my total. So I'll initialize my total by 0. And I'll also initialize my result index by 0 because I'm starting from the 0th index to check this, right? After that, for I in range length of gas, because I'm checking for the gas array. And what my total would be, my total will get updated as gas I minus cost I. If it is positive, positive. If it is negative, negative. That's what get updated in the total. And then I check if my total is less than 0. If it is less than 0, then I reset my total to 0 and I'll move to the next index. That's what I need to do, right? So my result cannot be this index since my total became less than 0 and I ran out of gas. So I have to check for my next index and my result would be I plus 1. So I update my result. And then finally, I have got some result. I just return that result. That would be my end index. So let's take an example. Say, suppose this is our example. We start from the 0th index. So here, our 1 minus 3 is -2. So total is less than 0. So they set total to 0 again. And our result will get set to 0 plus 1. That is first index. And then we again run through the loop. This is again -2. So our result gets set to second index. Again, we run through the loop and we see that it is -2. So it gets set to third index. And in third index, our total is positive 6. So we get 4 minus 1, 3 plus 5 minus 2, 6. And our total is not less than 0. The total comes out to be 6. And our result remains 3. So we can return the result. So that's the entire crux of the code. Now, time complexity using this approach would be O of n because you are running through the gas array only once and that too not fully, right? So the time complexity is O of n and your space complexity or your memory complexity would be O of 1, the constant space complexity. So that's the entire question. If you have a better approach to solve this question, I would suggest you mention it in the comments here. I would be happy to know it. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily lead code challenge. If you have some better questions you would like me to solve, also mention them in the comments. Share it with your friends, share it with your network so that I can reach the right audience. Thank you.